Hi, welcome to my course. It's Dr. Gurinderjeet here. I will be recording my lectures to teach machine learning. So I'm assuming that you are a very beginner in this field of ML, and I'm going to start with the very basic introduction to machine learning in my course. So I will be covering these key points in my first video. Let's start with the very basic goal of this course. So I'll be writing my key points here, just considering it as a whiteboard introduction to the beginners. So the first introduction section is to introduce the learners of this course to the role of ML. ML stands for machine learning in daily life. Like where do we actually use this ML in daily life, so that you can build an intuition about the concept of learning, how these machines are learning, and we are going to set the roadmap for the rest of the course. So first of all, imagine asking your phone in before the 90s, like in early 90s, for the directions. Like, let's suppose you want to go to a location like we use nowadays on the Google Map. So can you ask the directions on your phone in the early 90s? If you have asked, it would not have given you the directions. So people would have laughed or thought something was wrong with you. But today it's the very natural that you are going to ask some directions to reach a destination from your mobile device. So there is where in the back end ML is working. So this transformation from early 90s to the today's era hasn't happened overnight. It was possible by a branch of computer science called machine learning. Okay. So we are going to explore it together over the next coming couple of days. And first, let's keep it very simple. What is machine learning? Machine learning is teaching computers to recognize some kind of patterns, recognize some kind of patterns in data. And after analyzing those patterns, the machines do some kind of decision making without writing any kind of step by step rules like we do in most of the programming languages. We specify the steps, we take the input from the user, we specify the steps to reach a specific output for solving any kind of particular problem. But in this, we do not write rules. We provide the data, the machines figure out those rules on its own and are capable enough to make the decisions on their own. But in traditional programming, as I have already mentioned, we used to write these rules by ourselves. So you tell the computer exactly what to do, exactly what to do. But in ML, we give examples. This is not possible in ML. In ML, we are giving examples in the form of data, and it figures out the rules on its own. If I give some real world use cases, real world use case examples, which we can take right now, ML is not like not in the big tech companies. We are using it all around us in daily lives. So, like, let's suppose you turn an image, you click an image, you scan an image, and convert that into editable text. Let's suppose if you have not used this, you might have used the emails. So in emails, we have some inbox features like spam or not spam. So this feature is used to filter the junk emails from your email inbox. Like you might have used some virtual assistants, some voice assistants, like what should I say? Siri here, Siri, Alexa, Google Assistant. All these are daily uses of ML in your daily life. If you might have used some of the applications which are used to translate between different languages, so that is also an ML application. You might have used Netflix or Amazon Prime, some video streaming apps like that. Those provide recommendations of what you have watched in the past. Based on those things, it provides recommendations to watch in the future. So all of these things work by learning from data. What data you are producing, based on that data, it is learning the pattern, and it provides you better performance, like giving recommendations, filtering the spam mails. All those things works based on the data which you are providing, and it is able to work on its own. So, one task from my side, can you name one feature on your mobile or your phone or any computing device which you are using, any laptop that might use ML? So, this is the question which you need to answer it to yourself just to check your knowledge. Although it feels like a recent trend that we have got ML uh, recently, like last 10 years or maybe a few years more, but ML was there uh, before these decades also. One of the major examples, as I mentioned, was email spam detection, which was there in the early 1990s. And one of the other examples I can mention is optical character recognition, OCR. So these are some of the examples which was already there, which made us think that we can use this more to its extent. And nowadays, ML powers hundreds of features, often quietly in the background. You don't even know that it is using ML in the background. So, learning from example, not providing any rules, that is the basic idea of ML. Making predictions. I'll write the key points here. So, the key ideas which we have discussed till now is learning from examples, not rules. That is the basic uh, pillar of machine learning. Making predictions or some kind of classifications. It depends on what kind of application you are having, which is based on ML, and making your application to adapt to some kind of new information, adapting to new information. So these are the points which I need to address, and what we will be covering in the coming lectures. So in this course, I will cover the different areas of machine learning. First, we will be covering the theoretical concepts like supervised, unsupervised, model types like instance-based model type, model-based, some strategies to online learning, how to design, train, and improve ML models. So all these things we will be covering in the coming lectures. So coming back to the key points, I want to highlight them once again before concluding this lecture. So first of all, what is there in the first point? Machine learning is everywhere. So once we have seen that this is a science fiction, ML is used nowadays by billions of applications. So real world uses began decades ago, like in OCR application, but it is like increasing day by day. And ML became the mainstream in the 1990s. As I mentioned, spam filters was the first use case, which gave us this opportunity to explore this field in more detail. So these filters learn over time to detect and block unwanted emails. As I mentioned, that ML powers many everyday features. Some examples can be voice assistants, as I mentioned, Siri, Alexa, language translations, translating from one language to another, language translation. Another application which I can mention is image recognition. Nowadays, we have this feature in our phone where it can identify who is the person in the image and filter them together. Any kind of product suggestions which we are getting on our mobiles, on what data we are producing, based on that we are getting recommendations. All that is having the ML in the back end. And what does it mean by learning? What How the machines are learning? Let's suppose if I have the data. Let's suppose I am learning the data from Wikipedia. But what if we are not using that data? If we are not able to improve any task performance? So that is not learning. Learning is when you know something and you are able to do something based on that knowledge. So machines are knowing that data and able to make some kind of decisions, predictions, classifications, or whatever is the goal based on the application, based on what they have learned. What's the roadmap of this module? We will be covering everything from understanding what is ML, different types, ML workflows, system design, how to assess and improve the models. And the purpose of this chapter is to make you aware about the foundations of ML. Simple explanations, not much of the code, just the concepts made clear in this lecture, in the first module. So that's all what we need to make ourselves aware about the terminologies. If you have any doubts, you can write it back to me. I'll explain those things back.